Okay, this video demonstration is a quick example of dividing complex rational expressions. Now, what does that mean? Complex rational expressions are essentially fractions divided by fractions, but a little bit more complicated than that even. In this particular case, I've got a fraction minus a fraction divided by a fraction plus a fraction. And it looks like it's really tied up, so it's a little bit difficult to look at, but it really is not that difficult a problem if you look at certain parts first, which is, like a lot of math problems, you have to know kind of where to look in order to start the problem. So I'd like to go through these steps with you. When I see problems like this, I look immediately to the denominators and I ask myself, are they the same? And in this case, I notice that they're similar, but not exactly the same. So I need to basically get each of these denominators the same so that I can subtract, if you want, and add down here the different parts. The second thing I look at when I look at these type of problems are the grouping symbols or the division bars. If you remember PEMDAS, that kind of always gives you a hint about where to start. And in this one, I see there is a problem in the top that is different from the problem in the bottom, and I could treat those separately to make this a little easier. So this is what I'm going to do. Taking those two observations, I'm going to get the common denominator for all four of these denominators. And the common denominator would be AB. So I'm going to multiply this one by a B over a B. That's multiplying by 1, which again, remember, doesn't change anything. And I'm going to multiply this fraction by A over A. Now look what I've got there. I've got AB in that denominator, AB in that denominator. I'm going to do the same thing down here. I'm going to multiply by 1, which is just B over B, and this one down here, which is just A over A. Now if you take a quick look at that, you'll notice that I have a common denominator now in all four of my fractions. Now the cool trick about this one when I'm simplifying this is I get to cross those out now, because now all the denominators are exactly the same. And let me go ahead and rewrite what I've got left over so you can see how it's simplified. I've got 4b minus 7a, and in the denominator I have 9b plus 3a. Now probably the only thing I could do at this point is I really can't divide anything from up here and down here. But what I can do is I can, again, keeping this division bar as my grouping symbol, I can look up at the top and say, is there anything in that binomial that I can simplify? And there really isn't. Is there anything in that binomial that I can simplify? And there is, actually. There's a 3 that's common to both sides of the addition. So I'm going to go 4b minus 7a for the numerator, and I'm going to factor out a 3 in the bottom, and I'm going to go 3b plus a in the denominator, and that is my final answer. Okay, I hope that helped. Remember to look at the different denominators, multiply by 1 so you can get them the same, and also to look for the grouping symbols and just divide the problems up into smaller segments and do those. Okay, good luck to you.